Hello students, welcome to my channel Math Magic. Me Promish Sarkar. Today we will discuss about the chapter increasing and decreasing functions. Okay, this is most important in your class 12 book. If my video helps your study, share my videos and subscribe my channel. Okay, so let's start. So what is increasing? First of all, what is increasing and decreasing function? Okay, see, using graph. I draw a graph. See, this is x-axis, this is y-axis. Okay, first of all, we draw a graph along this. Okay, now we take 2 points. Suppose first one is x1 and second one is x2. Okay, now what is the value of y? That is fx1. Here is fx2. Okay, so see everyone, x2 is greater than x1. x2 is greater than x1. So see carefully, x2 is greater than x1, and that is why fx2 is greater than fx1. This is an example of increasing function. Okay, now see another way. Suppose x1 is, suppose see same graph. Okay, same graph. If x1 is here, okay, and x2 is here, okay, so here is fx1 and here is fx2. Okay, look here, x1 x2 greater than x1, but here is fx1 equal to fx2. Okay, fx1 equal to fx2. This is the another example of increasing function. So increasing function, see carefully, fx2 greater than equal to fx1, that function is called increasing function. Okay, now another strictly increasing function. See, strictly increasing function. So again we draw a graph. This is x-axis, this is y-axis. Okay, now suppose graph this way. Okay, here we take a point x1, here we take a point x2. So here fx1, here is fx2. Okay, now see carefully, x2 greater than x1, and that is why fx2 greater than fx1. That is the example of strictly increasing function. Okay, I repeat, this is increasing function. There is f2 greater than equal to fx2 greater than equal to fx1. That is increasing function. But here is fx2. Look at the graph. Fx2 greater than, only greater than, not equal to, greater than fx1. That is strictly increasing function. Okay. Now decreasing function. See carefully. Again we using the graph to better understand decreasing function. Okay. See decreasing function. Same way. Okay, see, this is x-axis, this is y-axis. Suppose this way. Okay, so here is x1, here is x2. Okay, now here is fx1, here is fx2. This is the value of y. Okay, now look, x1 greater than x2 and fx1 greater than fx2. Okay, now if we put x1 here, x2, x1 here, x2 here, okay, that means in a straight line. So in that case, fx1 equal to fx2. Okay, so we write therefore fx1 greater than equal to fx2. This is called decreasing function. Okay, this is called decreasing function. Now strictly decreasing function. See another graph. This is x-axis, this is y-axis. Okay, strictly decreasing function. Look, this is a graph of strictly decreasing function. Here is x1 and take another point, that is x2. Okay, on the x-axis take one point x1, another point x2. So here is the value of y, fx1, here is fx2. Okay, clear? In that case, x1 greater than x2, therefore fx1 greater than fx2, always fx1 always greater than fx2. That is why this function is called strictly decreasing function. Okay, so this is a decreasing function if fx1 greater than equal to f x2 decreasing function, if f(x1) greater than, only greater than, equal greater than f(x2), that is called strictly decreasing function. Okay, now in a simple definition we can say f be a real valued function defined in an interval, then f is called an increasing function if x1 less than x2, x1 less than x2, that is if x1 less than equal to fx2, that means fx2 greater than equal to fx1, and f is called strictly increasing function if x1 less than x2, that means if x1 less than fx2, that is strictly increasing function. Now another case, decreasing function, f is called decreasing function if x1 less than x2, that is why that is if x1 greater than equal to if x2 greater than equal to if x2, and f is called decreasing function, and f is called strictly decreasing function if x1 less than x2 and if x1 greater than if x2, that is called strictly decreasing function. Okay, now the condition for increasing and decreasing function, see by using graph. Okay, condition for increasing and decreasing function, see carefully. Another x-axis, here is y-axis. Okay, we draw a graph. This is a graph, a function. Okay, fx. So take any point on the curve. Suppose this one. Take any point on that curve. Okay. Now draw a tangent. Draw a tangent at that point. Okay. See carefully. Draw a tangent at that point. Okay. That tangent makes an angle theta with the positive direction of x-axis. Okay. Look, theta is an acute angle. Okay. So all of you know tan theta. When theta is acute angle, tan theta is always positive. I repeat, when theta is an acute angle, tan theta, the value of tan theta is positive. That means this is increasing function. Okay, that means tan theta, that means slope, that means derivative, first order derivative. We do the derivative of that function. We get the positive value. That means this is increasing function. Okay. Now decreasing function. In case of decreasing function, this is the condition. Decreasing function. See carefully. We draw a graph. Suppose this is a function of fx. Okay, now see, we take any point, in case of decreasing function, look at the graph. In case of decreasing function, this is a graph of decreasing function. Okay, take any point. Okay, take any point. This was, take any point. Okay, on the graph and draw a slope at that point. Now, look, this is theta. Okay, this theta makes an angle with the positive direction of the x-axis, that is obtuse angle. Okay, now see, in case of obtuse angle, all of you know tan theta is always negative. Okay, so in case of decreasing function, dy by dx, first order derivative is less than 0, that means negative. Okay, so in case of, this is the condition of increasing and decreasing function. Okay, I repeat, in case of increasing function, look, this is the graph of, okay, curve of increasing function. In case of increasing function, theta is an acute angle which made the positive direction of the x-axis, and tan theta is always positive. Okay, that means dy by dx equal greater than equal to 0. Okay, this is the increasing function condition of. Now condition of decreasing function, look, take any point on the curve and draw a tangent to the curve. This angle theta makes with the positive direction of the x-axis, that is obtuse angle. All of you know tan theta, when theta is obtuse, the value of tan theta equal to negative. Tan theta means slope, that means dy dx. So dy dx equal to negative. So this is the decreasing function. Clear? Now give some examples. All of you, again say, if a function is given, first of all we find the first order derivative, that means f dash x. So f dash x greater than equal to 0, this is increasing function. If f dash x greater than 0, only greater than, that means strictly increasing function. I repeat, when f dash x greater than equal to 0, this is increasing function. when f dash x greater than equal to greater than 0, that is strictly increasing function, and in case of decreasing, see f dash x less than equal to 0, that means negative value, that is decreasing function, and when f dash x less than 0, only less than, that means decreasing, strictly decreasing function. Clear? Note it. Okay, f dash x greater than equal to 0, increasing function. F dash x greater than 0, only greater than 0, that is strictly increasing function. F dash x less than equal to 0, decreasing function. F dash x less than 0, strictly decreasing function. Clear? Now give some examples, see carefully. Listen the question first. Question number 1. Okay, a function fx, that is given, a function fx equal to x divided by x square plus 1. X divided by x square plus 1. A function fx equal to x divided by x square plus 1, that is given. Now the question is, find the interval in which the function fx equal to x divided by x square plus 1 is increasing, number 1, number 2 is decreasing. Okay, so fx equal to x divided by x square plus 1, that is given. Now the question is, find the range of increasing and decreasing function. Okay, see carefully. First of all, we find the increasing. So first of all, we find f dash x. Okay, that means dy by dx of that function. So using u by v method, ddx of uv, ddx of u by v. Okay, using u by v method, we get the result is, after derivative, we get the result is x square minus 1 divided by x square plus 1 whole square. Okay, after differentiate of that function, we get f dash x equal to minus x square minus 1 divided by x square plus 1 whole square, using the formula of ddx of u by v. Okay, now see, all of you know case number 1. In case of increasing function, f dash x greater than equal to 0. Okay, that means we write minus x square minus 1 divided by x square plus 1 whole square greater than equal to 0, in case of increasing function, or find out the increasing function. Okay, see, so minus of x plus 1 into x minus 1 greater than equal to 0. Okay, so x plus 1 into x minus 1 less than equal to 0. Okay, we get this condition, x plus 1 into x minus 1 greater than equal to 0. So after solving this problem, we get x equal to 1, 1 is x equal to minus 1, another point is x equal to 1. Okay, now draw a number line, here is minus 1, here is plus 1. Okay, now check in which point or in which range the function is increasing. Okay, check in between minus 1 and plus 1. Look, in between minus 1 and plus 1, take any point. Suppose we take 0. Okay, suppose we take 0. Check f dash x. Okay, f dash x, put x equal to 0. Instead of x, we put 0. That means 0 minus 1, that is minus 1. Okay, in the numerator, and in denominator, here is 0 plus 1, that means plus 1. That means minus 1 divided by plus 1. So we get minus 1. Here is minus in front of this function. So minus 1 into minus 1, that is plus 1. Okay, so we find f dash x greater than 0 in between the range of minus 1 to plus 1. Okay, so in between the range of minus 1 to plus 1, this function is increasing function. Okay, so in case of increasing function, the value of x minus 1 greater than equal to x greater than equal to 1. In case of increasing function, the value of x in between minus 1 to 1. Look, minus 1 to 1. Okay, now sorry, the sign is reversed. In case of increasing function, the range is minus 1 less than equal to x less than equal to 1. Okay, in case of increasing function, see carefully, this is the increasing function. Now in case of decreasing function, see carefully. So part 2, in case of decreasing function, look, the value of x below minus 1 and upper plus 1. Check, below minus 1 we take minus 2. Any value, take below minus 1, that is minus 2. Put here minus 2 whole square, that is plus 2 plus 4. 4 minus 1, that is 3. Okay, that means plus 3. Okay, and here is also plus value. We get instead of x we put any value in the denominator, we get the plus value. So here is also plus value in numerator, and in denominator here is also plus value. Okay, so total whole function we get minus value. Okay, so in between below minus 1 we take minus 2, we get the minus value, that means decreasing function. Now upper of plus 1, that means more of plus 1, see more than plus 1, that means plus 2. We put plus 2 instead of x, we get 2 square, that is 4. 4 minus 1, 3, plus value. And here is put any value of x, we get plus in the denominator because there is square. Okay, so minus square, that means plus, and plus square also is plus. So we get total plus value, and in front of this there is minus, so minus, plus minus minus. So upper plus 1 or more than plus 1, we put any value instead of x, we get minus, that is decreasing function. So in case of decreasing function, x, the value of x, okay, less than equal to minus 1, and x greater than equal to plus 1. Okay, I repeat, in case of decreasing value, x less than equal to minus 1 and x greater than equal to plus 1. Okay, so how we write? X belong to, see carefully, minus infinity to minus 1 union 1 to infinity. Okay, 1 to infinity. This is the decreasing function range, and this is the increasing function range. This is increasing function range, this is decreasing function range. See carefully. Okay, come to the next example. Okay, example number 2. See carefully, example number 2. Listen the question first. There is a function that is given fx equal to, there is a function fx equal to, the function is fx equal to, the function is 2x cube minus 9x square minus 24x plus 5. 2x cube minus 9x square minus 24x plus 5. This is the function that is given. Fx equal to 2x cube minus 9x square minus 24x plus 5. Now the question is, find the range of values of x for which the function fx, this is given, is strictly increasing and is strictly decreasing. Okay, strictly increasing and strictly decreasing. Okay, now come one by one. Strictly increasing, that means greater than, not equal to, greater than equal to 0 in case of strictly increasing, and in case of strictly decreasing, less than 0, not equal to. Okay, greater than 0, less than 0. In case of strictly increasing, greater than 0. In case of strictly decreasing, less than 0. So find out the range. Number 1, strictly increasing. Okay, see, first of all we find f dash x, that means dy dx of that function. So f dash x equal to 6x square minus 18x minus 24. Okay, now take 6 as common. So we get x square minus 6 3 is 18, 3x minus 4, 6 4 is 24. Okay, now using middle term factorization, factorize this function. 6 into x square minus 4x plus x, 4 1 is 4. Okay, minus 4x plus x, we get minus 3 minus 4. So we finally we get x minus 4 into x plus 1. Okay, okay, x minus 4 into x plus 1. Now number 1, strictly increasing function. So in case of strictly increasing, this function, that means f dash x, must be greater than 0. Okay, so we, after solving this problem, we get the value of x equal to 4 and x equal to minus 1. X equal to 4, x equal to minus 1. Draw a number line. X equal to 4, x equal to minus 1. Okay, see, now check one by one. First of all, in case of strictly increasing function, okay, take any value of x below minus 1. Okay, take minus 2, just put it minus 2, that means minus 2 minus 4 minus 6. here is minus 2 plus 1, that is minus 1. Here is minus, here is minus. Minus minus multiply plus, we get plus. So here is minus 6, minus 2, minus 4, minus 6. Here is minus 2 plus 1, minus 1. So we get plus 6. Okay, plus 6 into 6, 36. That is plus value. This is strictly increasing. Okay, that means if the value of x less than minus 1, we get all positive value of f dash x. Clear? So x less than minus 1. Okay, if x less than minus 1, we get positive value. Now check more than plus 4. More than plus 4. Check plus 5. So here 5 minus 4, we get positive value. Just look at the sign, focus the sign, positive or negative. Okay. Now if x is more than 4, take 5. So value of x is 5. 5 minus 4, that is plus value. Here is 5 plus 1, also plus value. So plus into plus, that is plus. So plus value, we get plus value. So if x greater than 4, so we get plus value. Okay, if x greater than 4, we get plus value. So the range is if the value of x less than minus 1 and value of x greater than 4. Okay, so this is the increasing function range, strictly increasing function, not increasing, strictly increasing function. Now strictly decreasing. Okay, in between, look at in between minus 1 and 4. Take any value, minus 1 and 4. Suppose we take 0 in between minus 1 and 4. So put 0 minus 4, this is minus value. 0 plus 1, that is plus value. Minus into plus, that is minus. So in any value we take between minus 1 and 4, the result of f dash x is negative. That means strictly decreasing. Any value, suppose minus 1, then 0, then you take 1, you take 2, you take 3, just put it and check. This value is negative or positive. Take all the values. If we put instead of x in between minus 1 and 4, we take all the negative value. That means decreasing function. So what is the range? See, number 2. This is the range of decreasing function. See, minus 1 greater than x greater less than 4. Okay, this is the range of decreasing function range, strictly decreasing function. Okay, see, if number 1, if x less than minus 1 and x greater than 4, we get the strictly increasing function. And the value of x in between minus 1 to 4, in between minus 1 to 4, we get all the negative value. That means strictly decreasing function. Okay, look. Come to the next example. Come to the next example. Example number 3. See carefully. Example number 3. There is a trigonometric function. See, listen carefully, find the intervals in which the function a given by fx equal to, example number 3, given by fx equal to sin x plus cos x. Okay, and here is range is given sin x plus cos x, and here is range is given 0 to 2 pi. 0 to 2 pi. Okay, find the interval in this function fx equal to sin x plus cos x 0 to 2 pi. Okay, 0 to 2 pi. Increasing, number 1 increasing function, number 2 decreasing function. Okay, I repeat the question. If a function fx equal to sin x plus cos x, okay, sin x plus cos x, find out the range of increasing and decreasing, fx equal to sin x plus cos x in between 0 to 2 pi. Clear? Now, first of all, let's start to the answer. First of all, we find out the f dash x. Okay, see, therefore f dash x, first order derivative, sin x equal to cos x equal to minus sin x. Clear? sin x equal to cos x equal to minus sin x. Okay, now multiply root over 2. So we get 1 divided by root over 2 into cos x minus 1 divided by root over 2 into sin x. Okay, now root over 2 into 1 by root 2 means sin pi by 4. Sin 45 degrees. Sin pi by 4 into cos x minus cos pi by 4. Cos pi by 4 into sin x. Okay. Okay. Now see here sin A cos B minus cos A sin B. This is the formula of sin A minus B. So we write root over 2 into sin pi by 4 minus x. Now take minus as common. So minus root over 2 into sin x minus pi by 4. Okay. We get the f dash x, we get the value of f dash x equal to minus root over 2 into sin x minus pi by 4. Okay, now check one by one. Number one, increasing function. Number one, increasing function. So see this function, okay, in case of increasing function, that means f dash x must be f dash x greater than equal to 0. Okay, all of you know f dash x greater than equal to 0 in case of increasing function. Now see minus root over 2 into sin x minus pi by 4 greater than equal to 0, or multiply both sides by minus root over 2. So we get sin x minus pi by 4 less than equal to 0. Okay, now check in which angle or which value of this angle the sign is negative, that means less than equal to 0. See carefully, in between pi to 2 pi, range is 0 to 2 pi, that is given. Okay, so in pi to 2 pi, the value of sign is negative. Okay, look at the condition. So find out the increasing function. See carefully, pi less than equal to x minus pi by 4 less than equal to 2 pi. Clear? Now add pi by 4. Therefore pi plus pi by 4 less than equal to x less than equal to 2 pi plus pi by 4. Okay, so we get 5 pi by 4 less than equal to x less than equal to 9 pi by 4. Okay, but the condition is 0 to 2 pi. So what is the increasing function range? That is, increasing function range is 5 pi by 4 less than equal to x less than equal to 2 pi. Okay, 9 pi by 4 cross the 2 pi. That is why we write 5 pi by 4 less than equal to x less than equal to 2 pi. Okay, this is the range of increasing function. Now another, look, suppose 0 to here, if we put the value of x 0 to pi by 4, check what happened. We put the value x 0 to pi by 4, any value. Okay, suppose 0, we put 0. So 0, that means sin minus pi by 4 minus. Okay, again, suppose 30 degree, that means x equal to pi by 6 put. So if we put x equal to pi by 6 minus pi by 4, that is also minus. Okay, that means another range, that is 0 less than equal to x less than equal to pi by 4. This is two range of increasing function. This is important sum. Look carefully, see carefully. Important sum. This is the range of increasing function. Now decreasing function number 2. Okay, this is the range of increasing function. Now in case of decreasing function, all of you know f dash x less than equal to 0 in case of decreasing function. So we write therefore minus root over 2 sin x minus pi by 4 less than equal to 0. Okay, now multiply both sides by root over 2, minus root over 2. So we get sin x minus pi by 4 greater than equal to 0. Now tell for which value of this function is positive. Okay, which value of x the function is positive? See carefully. Okay, sin 0 to pi 0 to 2 pi 0 to pi 0 to pi, put any value. 0 to pi, that means first quadrant and second quadrant. All of you know, in first quadrant and second quadrant sign is positive. So this condition is satisfied. Okay, now see. So this is the range of this is the range of 0 to pi. Okay, so therefore 0, okay, less than equal to x minus pi by 4 less than equal to pi. Okay, now add pi by 4. Therefore pi by 4 less than equal to x less than equal to pi plus pi by 4, that is 5 pi by 4. Pi plus pi by 4, that is 5 pi by 4. Okay, so pi by 4 to 5 pi by 4, this is the range of decreasing function and this is the range of increasing function. Clear? Hope all of you clear. So hope all of you understood. Thank you, students.